All right, let's jump into something you all requested, vacuum forming.
Ooh, vacuum forming.
Whether you're just curious about how things are made or maybe need to brush up for a meeting, get ready. We're going to have some aha
I
moments.
love aha moments.
Yeah, you and me both. So we've got a whole stack of info here.
That.
Stack? We're going to pull out the best bits just for you. So vacuum forming, I think a good way to visualize it is, like, imagine a sheet of plastic doing yoga. It heats up, it stretches, and then it holds a pose,
That's a good analogy.
all thanks to, like, some suction. And it's surprisingly behind a lot of stuff we use every day.
You know what's really interesting about it to me is that vacuum forming really does take an idea and it makes it like a real tangible object. So it all starts with a mold.
Right.
And that mold is like a blueprint.
Yeah.
And they can be made out of different materials like aluminum, wood, sometimes even plastic itself.
So it's like picking the right tool for the job from your toolbox, so to speak.
Absolutely, yeah. It just depends on what you're making and how durable it needs to be and the cost and how complex the design is. All those factors go into it.
So once you've got the mold, you secure this plastic sheet above it,
Mm-hmm.
and then you heat it up. They use these things called radiant heaters.
Radiant heaters, yeah, those things get hot.
Yeah, they do. And that's what gets the plastic all stretchy, all ready to be, shaped.
Yeah. And then this is where the magic happens. That hot, flexible plastic sheet is just hovering over the mold, and then a vacuum is applied from below.
From below.
Yeah. And it sucks it down, forcing it to take on the shape of the mold, like a three-dimensional imprint.
Wow. So it's incredible how this flat sheet can become something like with depth and shape.
Yeah.
And it happens like instantly.
Yeah.
And then it cools and it hardens and it locks in all those details.
Exactly, yeah.
But why is this method so popular? Why do we use it so much?
Well, there are a lot of reasons, but I think one of the main reasons is cost effectiveness, especially if you don't need to make a ton of these things.
Oh,
So like for prototypes
Oh, yeah.
or special edition products, things like that, vacuum forming molds are relatively cheap to make compared to the other methods that are out there. And the whole process is like pretty quick.
so if you need something done like ASA,
Yeah.
vacuum forming's your best friend.
Pretty much.
Now, I see from our sources here that it's used a lot for food packaging,
Yes.
automotive parts, even toys. So we're not just talking like simple shapes here. This can handle some detail too, right?
Oh, yeah, absolutely. But like any tool, it does have its limitations.
So it's not like a one-size-fits-all manufacturing solution.
Right.
What are like the drawbacks?
Well, while it's flexible, vacuum forming really shines when you're working with parts that aren't like super deep or super intricate.
Okay.
So think of it this way. Imagine you're trying to like vacuum form a Lego brick.
With all the little...
Yeah, all those little bumps and holes.
Yeah.
Probably wouldn't work out too well.
Right. Certain shapes would be a real challenge for that hot plastic to like perfectly conform to.
Mm-hmm.
Now, our sources also mentioned that this process isn't ideal for like mass production, large-scale manufacturing.
Right.
Why is that?
Yeah, that's a good question. So while it's super efficient for smaller batches, it can't really compete with methods like injection molding when you're making thousands
Oh, okay.
or even millions of identical parts.
Right.
The cycle time, the time it takes to make each piece is just longer with vacuum forming.
So it's like a trade-off, right?
Yeah.
You get customization, you get speed for smaller batches, but you sacrifice that mass production power for large quantities. It's fascinating how each of these processes really has their own niche.
Yeah.
But tell me, are there ways to tell if something's been vacuum formed just by looking at it?
Yeah, there are. There are definitely some telltale signs. Keep an eye out for smooth surfaces.
Smooth surfaces,
Right.
okay.
Consistent thickness throughout the piece. And you'll often see these little faint lines where the two halves of the mold came together.
Oh, wow.
It's like a little manufacturing fingerprint.
That's so cool. I'm never going to look at a plastic container the same way again.
Yeah.
But this kind of leads me to another question. If vacuum forming is best for, simpler designs, what about those really intricate objects, the ones we see every day, like electronics or medical devices?
That's a great point. It really raises the question, what other manufacturing methods are being used when we need to create those amazingly detailed, complex forms?
Right. It's like we've zoomed in on this one fascinating technique, and now we're ready to zoom out and see how it fits into like the bigger picture of manufacturing.
Exactly. This deep dive's just the beginning. Now let's switch gears a bit and explore some real-world examples of this, because vacuum forming is like hiding in plain sight all around us.
Okay, I am ready to be amazed. Let's see how this like simple concept is shaping the world we live in.
Let's do it. Let's start with something like super common packaging.
Okay, packaging.
So those clear plastic clamshells that you see protecting your baked goods or electronics,
Oh, yeah.
vacuum formed.
Really?
Yeah, it's perfect because you can like create these protective barriers that are lightweight, visually appealing. They let the product shine through.
So next time I'm like wrestling with one of those clamshell packages,
Yeah.
I'll take a moment to appreciate the ingenuity behind it. What other like everyday examples can we think of?
Well, think about the dashboard in your car, all those curves and contours, the housing for your instrument panel.
Oh, yeah.
That probably involves vacuum forming.
Mhm.
It's great for creating like complex shapes that would be hard or expensive to make with other methods. Plus, you can texture the plastic, to make it look like leather or wood.
So it's like the chameleon of manufacturing,
Kinda, yeah.
adapting to different needs and aesthetics.
Yeah.
It's impressive how it kind of brings together both form and function.
Yeah.
Now, our sources also mention toys. Are we talking like those simple plastic figures from when we were kids?
Not just simple figures, think they're action figures with all their detailed costumes and accessories.
Oh, yeah.
Or those play sets with all the intricate components.
Yeah.
Vacuum forming lets manufacturers create toys that are durable, they're lightweight, they've got all those cool complex shapes and textures,
Yeah.
perfect for imaginative play.
Oh, absolutely. It's incredible how this one process can touch so many parts of our lives.
Yeah.
If we dig a little bit deeper here, though, are there limitations in terms of like the types of plastics that can be used?
That's a really important point. While vacuum forming can work with a range of plastics, they all have their own properties and best use cases.
Right.
So, for example, polycarbonate, it's really strong and impact resistant,
Oh,
making it perfect for things like safety gear. Then you have ABS plastic. That's got a great balance of like strength and flexibility, so that's
Mhm.
really popular for like consumer goods.
So it's not like a one plastic fits all kind of deal.
Exactly, yeah.
Choosing the right material really depends on the application, the desired outcome.
Yeah.
This is more complex than I originally thought.
Oh yeah, there's a lot to consider. And the choice of plastic can also affect the details and the finish of the final product.
Oh, okay.
Some plastics are just easier to mold into those intricate shapes than others, and some can be, textured or coated to create different effects.
So it's like this delicate dance between like the design intent,
Right.
the properties of the material, and then what the vacuum forming process can actually do.
Absolutely.
Wow, it's amazing how many like different factors are at play here.
Yeah, it's a whole process.
I'm curious though, are there any like recent innovations in vacuum forming technology? Like, has this process evolved at all?
Oh, absolutely. This industry is constantly innovating to try to make things more efficient, improve the quality. For instance, some manufacturers are using like robotic arms to manipulate the plastic sheets.
Really?
Yeah, and it just increases the precision and cuts down on waste. You also have advances in heating technology, things like infrared heaters.
Right.
They give you like more control over the heating process,
Mhm.
which can lead to, faster cycle times.
So it's like this cool blend of like traditional techniques and cutting edge advancements all coming together.
Exactly.
But speaking of limitations, earlier we talked about how vacuum forming isn't great for those really complex designs.
Right, right.
Are there any like workarounds for that?
Well, sometimes you can like assemble multiple vacuum formed parts together
Wow. Okay.
to create a more complex object.
Makes sense.
You can also combine it with other manufacturing methods, like 3D printing, for example.
Oh, interesting.
Yeah, so you could 3D print a part that's really detailed and then use vacuum forming to create like a lightweight, durable shell around it.
So it's not always like an either.
Right.
Sometimes combining those different approaches can lead to some pretty innovative solutions.
Exactly. And that collaborative spirit is, especially important when you consider the environmental impact.
Oh, yeah. Of course.
While vacuum forming generally, produces less waste than some other methods, there are still efforts to develop more sustainable materials and recycling techniques.
That's really encouraging. It's great to hear that sustainability is becoming a bigger focus in the industry.
Yeah.
This deep dive has definitely like broadened my perspective on vacuum forming. It's way more nuanced and versatile than than I
Okay.
initially thought.
It really is, and there's still so much more to learn about it.
I bet.
But before we wrap up, let's go back to that question that you asked earlier
Yeah.
about, if vacuum forming is best for simpler designs, what happens when we need to create those super intricate objects with all the tiny details?
Yes, that's what I'm dying to know.
Okay.
What other processes are being used to make things like microchips or medical implants
Right.
or those tiny gears in a watch?
Yeah.
How do they achieve that level of precision and complexity?
That's a perfect transition into like a whole other realm of manufacturing where things get microscopic and the techniques are like mind-boggling.
Okay, I'm on the edge of my seat.
Yeah.
Let's unpack these miniature marvels
Yeah.
and see how they're shaping the world from the inside out.
Mm-hmm.
Okay, so we've explored this world of vacuum forming, right?
Yeah.
Where we see these plastic sheets transform into all these objects that we use every day.
Exactly.
But what about those teeny tiny, like intricate components?
Right.
The ones that we rely on every single day.
Yeah.
It boggles my mind to think about the process involved in creating something like, a microchip with all of its microscopic circuitry.
Yeah, you're right. We're talking about like a whole other scale and level of precision here.
Right.
So when we talk about intricate objects like that, we got to talk about microfabrication.
The microfabrication.
Yeah, and this is where techniques like photolithography come in.
Photolithography. That sounds like intense. Is that anything like developing like a photograph?
There are actually some similarities.
Okay.
So it involves using light to transfer a pattern onto a material.
Okay.
Usually it's silicon.
Okay.
So imagine like creating a stencil but with insanely fine detail, and then you shine light through that stencil to etch the pattern onto a surface.
So it's like creating a miniature blueprint with light
Basically, yeah.
and then etching it permanently onto the silicon.
Yeah.
That's incredible.
Yeah.
But how do they achieve that kind of precision at such a tiny, tiny scale?
That's where it gets really fascinating. They use specialized lenses and lasers
Right.
to like focus the light with extreme accuracy. We're talking like down to nanometers.
Nanometers. It's hard to even imagine.
I know. And this whole process, it happens in a clean room
A
environment.
clean room, okay.
Yeah, because like even the tiniest dust particle could just ruin everything.
So it's like the ultimate test of precision and control.
Pretty much.
But what about like three-dimensional structures?
Yeah.
How do you go from like a flat silicon wafer to all those intricate components?
Right. So that's where techniques like etching and deposition come in.
Okay, etching and deposition.
Yeah, so etching is used to like selectively remove material, creating these tiny grooves and channels.
Okay.
And then deposition involves like adding layers of different materials to build up the structure.
Wow.
It's like sculpting on a microscopic level,
Okay.
adding and subtracting material. It's just incredible precision.
It's amazing to think that like these tiny, tiny components, invisible to us, are the building blocks of our entire digital world.
I know, it's wild.
But what about like other examples of intricate objects? How are things like, medical implants
Right.
or the delicate gears in like a watch?
Yeah.
How are those manufactured?
So for those kinds of objects, you're usually looking at precision machining.
Precision machining. Okay.
Yeah, and this is where specialized tools like cut and shape materials with ridiculous accuracy. So think of it like a miniature workshop with like tiny lathes and mills and drills all working on this microscopic scale.
So it's like a blend of like artistry and engineering,
Absolutely.
where these skilled craftspeople are using these really advanced tools to create these like miniature masterpieces.
Yeah, that's a great way to put it.
But, with all this focus on precision and technology, what about like the human element? Where does like craftsmanship fit into these really intricate manufacturing processes?
Oh, craftsmanship is still so important. Even in the most high-tech fields, the people operating these machines, the people designing the tools and the processes,
Right.
they're highly skilled individuals bringing their expertise and judgment to every single step. It's like a true partnership between technology and human ingenuity.
That's really awesome to hear. It's like this reminder that even in a world of, automation and these high-tech advancements, human skill and creativity are still essential.
Yeah, absolutely.
Well, this deep dive has been a fascinating journey, I got to say.
Yeah.
Taking us from this macro world of vacuum forming
Yeah.
to the micro world of microfabrication
Right.
and precision machining.
It's amazing, the range.
It really is. It's given me like this whole new appreciation for the hidden complexities behind all the objects we use every single day.
Me too. I totally agree. And you know what? There's always more to learn and explore.
Yeah.
Every object has a story to tell, a journey from like its initial concept to creation, and it often involves this amazing combination of like human ingenuity and technological innovation.
That's awesome. Well, to our listener, we encourage you to keep exploring,
Yes,
keep questioning,
keep being curious.
and keep looking at the world with those curious eyes. You never know what hidden marvels you'll uncover.
Absolutely. Until next time, keep diving deep.